Good morning, everybody. It's very early in the day, and we have the pleasure to have a panel who gives some reflections on the role of pilot lines on innovation. There's been long discussion in the forefront of Horizon 2020. How far should the support go? And some candidates will explain a lot on the pilot line topic. And the major question is, have we been successful in the last 2 to 3 years to activate this instrument, and what are the experience? The organizers alerted me that if you have any questions later on the topic, please use the second line, the Slido, and it was introduced yesterday also in the panel. I will see your question popping up here, and then we can try to ask as much of them as we can do. I already would thank the organizers. For the speakers, there is a clock there, and everybody has around 15 minutes, so have a view on that one. After 10 minutes, you might already have your conclusion. And without further ado, and welcome everybody, I would, Anne, to start off the topic, and maybe you can all introduce yourself, saves us some time on the topic. Thank you.
Okay, thank you very much, Gernot. So yes, I will start with my presentation. As Gernot has introduced, I will show you some experiences that Tecnalia has in this instrument, pilot production plants and facilities. So let's go to the contents of my presentation. I will first talk about the market potential that we have identified. I will mainly base my presentation in experience of 2 pilot plants. So I will give some figures about market potential. I will explain the nano-enabled solutions we are addressing. Then I will talk about some implementation perspectives and also access to financial capital, which is very relevant currently in this topic, and then give some policy recommendations. First of all, let me introduce you Tecnalia. I am the Director of Programs within Tecnalia, within one of the 6 divisions of Tecnalia. So we are Applied Research and Technological Development Center. And so we have 6 divisions. You can see here in the slide. And the biggest division is Industry and Transport. And I work there trying to find new opportunities in the public funding programs, mainly in Horizon 2020 and European funding. So we are 1,400 researchers, 50% of them are men. Our income is over 100 million euro, and we have a lot of patents, 21 requested, 94 in the portfolio, and 378 active, and we are working with more than 4,000 companies. Just briefly let you know that we have several clusters, that one is on ICT, but the other one in nanotechnologies, which are making a transversal work within all the divisions and all the technologies that we are addressing in Tecnalia. And of course, we have a global presence, but I want to mention that we have created the last 2 years Tecnalia Ventures, which is a 100% owned company by Tecnalia, and tries to overcome the valley of death and create, commercialize, exploit the results of our research. Okay, so very quickly, market potential of the technologies of the pilots that we are addressing. First of all is global market, thermal spray, the global market. So you can see that Europe here is a big player, and the total turnover is 7,000 million euro, and Europe, the market share for Europe is around 30%. Of course, USA and Canada, they have around 37%. But specifically, if we talk about high-velocity oxyfuel, one of the technologies within the thermal spraying market, and is the technology that we are addressing in one of our pilots. And the annual market is around 300 and 400 units, so we are talking about 30 to 60 million euro. If we go to other market and other figures, I would like to mention automotive sector, but the share of light components in automotive sector, and you can see on the left-hand side that is an increasing market, growing market, and depending on the type of vehicle, we can see that the introduction of plastics and composites in automotive sector is increasing in the last year and has a very good perspectives for the future. Also mention construction sector and equipment and machinery, equipment and machinery components. And this is also an increasing, growing market. And we can say that it's growing 3.5% in the last years and has good perspectives for the future. So which type of solutions we are addressing with our pilot lines? Okay, the problem, for example, could be in one of the pilots that the industrial machinery sector requires production processes that allows improving the durability of metallic components and increasing the efficiency of manufacturing process. So this is a hydraulic engine, and you can see that one of the components is a valve plate, and one of our pilots is trying to improve this valve plate. So we have developed a solution. It's a cost-effective industrial process to improve the durability and increase the efficiency in industrial machinery. It's a thermal spray and this high-velocity oxyfuel technology system pilot facility. And it's a solid deposition of nanostructured coatings by high kinetic efficiency and plastic deformation that will improve the wear properties and reduce friction for the surfaces comparing to existing manufacturing processes. So just to let you know, show you, I'm talking about is a Nano2 industry project. This is an ongoing project funded by this pilot instrument, and this is one of the pilot, and this pilot is called Tribonano. We put specific names of each of the pilots because it's improving the tribological properties of components. But we have another two pilot lines within the same project. These pilots are the idea is to develop or scale up these pilots within industrial plants because this project is Nano2 industry is trying to upscale the pilots from TRL5 to TRL7, so it's, let's say, an innovation action. And the other pilots, maybe just, this is the one I have explained. It will be placed in Emilia-Romagna in Italy, in Bonfiglioli Riduttori, is an Italian company. And the access is private. This is one of the, let's say, discussions currently about the pilot production facilities. Should they be open? Should they be private? But of course, if we are talking about TRL7, then the pilot facility will be placed in an industrial plant. So the access is private because of confidential aspects and because of the owner, let's say the Bonfiglioli, the industrial company, really is saving the confidentiality aspect of the technology. Then next pilot within this same project is a nano-reinforced metal casting technology to improve the hardness and resistance to temperature of Schwarz plate. This is another plate, different plate. And the sector we are working for is construction agricultural machinery sector. And the name we put is hard cast because we are improving the hardness of this component. So again, we are working in other different regions. And this is Lombardia. And the owner of this pilot facility is Fonderia Mora Gabardo in Brescia. Access is private again. And the third pilot is a nano-reinforced thermoplastic plus nanotexture surface for the B pillar So we are working for automotive sector here. And the properties we are obtaining is anti-scratch and aesthetic properties for the automotive sector. So this pilot is based in the Basque region, and the partner owner is Mayer. Mayer is an industry working for tier 1 and tier 2, depending for automotive industry, but within the Mondragon Corporation industrial group. Again, the access is private. But I want to show you another example, another pilot. We are also coordinator of this other pilot. The name is Platform, and Platform is an open access pilot or project, let's say, that again has 3 different pilots. It's a network of pilots, but in an open form. So the regions are Basque region, because Technalia is the coordinator, Patras in Greece, and Warsaw in Poland. And maybe for the discussion afterwards, here Platform could, in the future, open the access to new pilot facilities, could be a network of different pilots and the idea is to open the access of participation for SMEs. So the idea here in Platform is to develop nano-enabled products based on carbon nanotubes, and we have 3 different technologies. On the one hand, Bucky papers. On the other hand, CNT carbon nanotube doped non-woven veils. And we also are working with a pilot for Preprex. So the 3 different pilots, 3 different technologies for manufacturing this carbon nanotube material, let's say, for further manufacturing composite for automotive and aeronautic sectors. And a bit more explanation about the 3 regions that Platform project has inside, and in the consortium with all the value chain for manufacturing this carbon nanotube material. Which type of nano-enabled solutions we are bringing to this new material? On the one hand, lightning strike protection, de-icing capabilities for aeronautics, EMI shielding applications, fire protection, alternative fuel cells also could be applied in defense applications and also in the energy sector. Now, I would like to give some pilot implementation perspectives. I would like to let you know which are the main challenges that we are addressing in these 2 examples of pilot projects that I have explained. First of all, we are members of the recently created European Pilot Production Network. This is a network that has been created by the European Commission. And the basis for creating this network is that, development of pilot lines is crucial pillar for bridging the valley of death. And this is a conclusion that NanoFuture studies said recently. And also another statement is that to develop a pilot line is not enough. So we need to develop a package of activities to reduce the economic risk, and also we need to boost investment. Because I have mentioned 2 examples of pilot lines. One is going to address TRL 7. The other one, Platform, is at lower TRL. It was a research and innovation action, so the TRL starting point was TRL 4, then we will reach TRL 6. But after the project and after the European funding finishes, then we need additional investment. We need to boost, we need to upscale these pilot production facilities to next step. So this European Pilot Production Network has the commitment to support the pilot production. And the idea is to get the cooperation with other policy levels, the member states and the regions, This is a very relevant cooperation for the pilot production facilities, as well as other stakeholders like industry, research, private investors, and so on. And also, they have the commitment to involve other relevant initiatives, including other directorates like DG Grow, DG Regio, EASME, and platforms, European initiatives like NanoFuture and European technological platforms, and also national contacts and so on. Okay, so now if I would like to let you know a little bit which are the main, yes, time is finishing, but very quickly, platform is trying to get safe and sustainable nano-enabled products. So the process repeatability is very relevant in these 3 pilots. And then we want to get an homogeneous material. We want to get an efficient process, costly efficient as well process. And the metrology is very relevant. We need to characterize online, measure online the material we are getting. And so standardization has to be robust. We need maybe new standards to standardize this material. And the impact will be the industrial uptake. And we need a regulatory framework for this. So the research activities mainly are focused on this online monitoring of process, analytical technology, and also in the automation of the whole process. And then if we come to ISADI, to the other pilot example, pilot project, here the main aspect is to develop products safe by design, and also this control in real time that I think that in all the pilots that we are working with is a relevant topic. I want to mention also the business model. We are addressing business models for each of the pilots. We are looking for the value proposition. We are looking for the key activities, key partners, which are the customers, which is the relationship with these customers, which are the customer segments, and of course, which is the revenue stream and cost structure of all these pilots. And then very quickly comment on access to financial capital. Of course, we are working in the center here in Horizon 2020 project, but then we need to see how we will get new investment, how we will get new stakeholders for our pilot. And EU Grade, I would like to mention, is a project that is addressing the combination of funds, which is, I think, is a very relevant topic currently to support somehow the development of these pilot facilities. And within the investors, we can mention the government grant providers, but also regional funding providers, and banks, and business angels, and venture capitalists. And EU Grade is working on this direction. And very soon, they will have conclusions at the end of this year. Okay, finally, policy recommendations. We need pilots, mainly open access, for commercializing distinctive and disruptive innovation, and give SMEs the access to the possibility of accessing research facilities. We need a support to reduce the risk and boost the business opportunities. So we need capital-intensive business for reindustrializing Europe. Then the standardization and smart regulatory aspects are a very relevant topic we need to address. We need to work on a safe and protective way for the human health and for the environment as well. And of course, we don't have to forget the fostering the talent and skills for innovation. And that's all from my side. So thank you for your attention, and I will be happy to answer any question afterwards that you may have. Thank you.
Thank you, Anne, for this comprehensive overview of what's possible with pilot lines. So without further ado, I'll just hand over to Hermann Schuh. As I see here, he's the CTO of a startup company. So the claim that pilot lines are essential for SMEs and startups, I'm looking forward.
Yeah, this startup you mentioned already went bust, so that is no longer existing. We were too soon in that sense. I am working at the Hol Center in Eindhoven, which is an open innovation research organization, and a combination of both IMEC from Belgium and TNO from the Netherlands. We work on flexible electronics and on wireless autonomous microsystems and combinations of the two technologies. And we do this in, as I mentioned, open innovation mode with a large number of industrial partners who pay most of the research we do. In our research programs, we often start with, let's say, exploratory topics, often linked to academia. So we have close connections to many universities. We have some time-sharing positions there in universities. And we bring the ideas that pop up to a level where it becomes interesting for our partners, the companies, to take them serious. We go for demonstrators, we do validation of the ideas, and we lift it to TRL 4. But also, and this is, I would say, the bulk of our activities, we move on towards pilot line scale facilities, building real machines, building up know-how on processing, together with these industrial partners. And there you end up, in the end, to TRL 7. And I think this is what is often missing, really scaling up, looking at things like yield, etc., which hampers, let's say, the uptake of innovation in industry. Now, one of the goals in our manifesto, if you want to call it that, the Hol Center, is to create R&D ecosystems, especially, of course, in the Eindhoven region, in the Netherlands, but also in the European community. Our approach there is to align with our partner companies on roadmaps, and these then determine the goals for our research. Validation is a very important point here. In all the research we do, all the programs we run, validation in real cases, industrial cases, is of high importance. To give you some examples of pilot line facilities that we have built up in this open innovation mode. So this is not yet EU funded. This is just together with companies and some national funding. We built, for instance, a machine that can deposit moisture barriers on plastic films, which can then be used as a substrate for things like OLEDs and organic photovoltaics, and protect this from the environment. I won't go into the details of, let's say, the performance levels of the pilot line here, but it is now the best performing barrier film that is available. We have transferred this to companies. There are companies now on the market with these machines, and there's companies who try to sell these foils as well. And we continue to develop the technology, of course. By the way, to show you this machine, it doesn't show very well in this picture, but it's about 4.5 meters high. So this is really scaled up technology. And of course, the processing know-how that you have to have together with this machine is part of what we have developed also. Another example is on roll-to-roll equipment for deposition of active layers for organic semiconducting layers for OLEDs and OPV, where we have made real innovation in the sense that in this roll-to-roll machine, the foils go through all these different steps without ever something touching the top side of this film, which is of real high importance for creating really reliable devices in the end. So that's something we then also put into real life, and we created this pilot line again, together with a number of leading companies who have now also this in their product portfolio. Now the next step, and that is something we have basically started beginning of this year with the PyScale project, which is mentioned here, but also in a recently granted proposal in scope and a national program on thin film transistors. We are moving towards a larger consortia, so not just internally in the whole center, in this open innovation center, but we are teaming up with European partners and offering services based on these pilot line facilities. As we have a number of components that in the end are needed to create products, and other partners that we have teamed up with can offer, let's say, complementary parts in this pilot line approach, we can now also offer complete products and also the integration of products based on flexible OLEDs, based on hybrid electronics, and also based on thin film transistors. And these are just some examples of, let's say, active devices that come out of these pilot line approaches. Now, the PyScale project, as an example of, let's say, the approach here, is, of course, an EU project. So that's, let's say, a nice bridge towards what we're talking about here. Is offering flexible OLED services. And that means that we test and scale up new product ideas together with customers. We have 4 major launching customers inside the consortium, and we're also already open for external customers for the pilot line service. So there is, let's say, a closed consortium called PyScale, and we're now building up a pilot line service that will exist also after finishing this project, which can serve customers. It's open access in that sense. And actually, just a week ago, we already signed up our first paying customer for this service. And that's, for me, that's the biggest success story we can show when it comes to these pilot line services. The fact that we have been teaming up with other strong partners, now are offering a complete package in this pilot line project, enables us to really serve customers, really serve people who are interested in the end products and not just building up know-how on how to do something themselves. Well, at the core of this project are 4 large RTOs in Europe. So that's the whole center, it's Fraunhofer, VTT and CPI. We have linked to a number of major material suppliers and equipment suppliers. And as I mentioned, we have a number of launching customers, and already, let's say, we are opening up for new partners there. The interesting thing of this approach is that even though this is scattered, the infrastructure, the know-how is scattered all around Europe, we have one single approach towards these customers. They are coming in, let's say, in sort of a front office approach, and then guided through this whole pilot line service until they have their products on their desk. As I mentioned, it is a distributed pilot line, so we have made combinations of the best available processes, the best available infrastructure in Europe. For instance, in Hall Center, but also in Fraunhofer. And all these, CPI and VTT, all these RTOs have invested, often together with the European Commission, quite a lot of money and effort into building this knowledge base, building the infrastructure. And this is the first time we can actually make a real combination which can offer a commercial service in the end for customers. And I think that is the strongest point for continuation also of such pilot line approaches. Just an example of the distributed pilot line process flows. We use, as you can see here, this is mentioning the organization that is offering part of this, this process flow. So we start at Holst Center, we go to Fraunhofer, CPI comes in, Fraunhofer and Holst again, and then VTT finishes up in a final product. We have a number of these process flows for different kind of products, and it's all about making the optimum combination here. And this has enabled us now to do things we could not do ourselves. Neither of the RTOs could do what we can now do together, namely offering large size, reliable, flexible OLEDs. And I think this is making this pilot line facilities and what we have to offer as RTOs much more mature. The fact that we plug in parts that are best in class in this pilot line service really offers a big opportunity, not just for the RTOs themselves, but also for companies who can make use of this, this service. And I think this is something that will continue. We'll continue to add also parts in this process flow, in the project that we can offer. Maybe even by adding additional partners. So what, at least to my knowledge, is really important is as technology matures inside RTOs, it is a good reason to go for scale-up activities in joint pilot lines, in combined pilot line services. I think what would also be a next step, which is not yet there, would be to go for real foundries. So now we're offering services that are on a prototyping scale, so hundreds, thousands of samples. But going for real production is something different. And in some cases it may be needed to invest in real foundries there. What's also important is to make sure that the long-term business plan, and the previous speaker already mentioned something about that, are aligned. Not just between the RTOs, but also with funding agencies, etc. And for us also very important is to link to pilot lines or the pilot line approaches to mass manufacturers. So we are in close contact already, for instance, for the Pi-scale project with European manufacturers who can make large-scale OLEDs at some stage, based also on what we have done with the customers. A next point is to make sure that in pilot line approaches you have specialization. So we all start with a broad spectrum of technology, but in the end you should focus on those tasks, those topics which you can really offer the best in class, and not keep continuing investing, funding, let's say me too research, but really make sure that you focus on the part in the chain that you can do the best. And finally, one thing I'm missing, especially in Western Europe, is entrepreneurial spirit. We see that in universities, very often there's limited numbers of people starting up companies. If they start educating people with, let's say, entrepreneurial skills, you already see a big increase there. If you also start supporting them financially and by coaching, they can also be successful in many cases. But the biggest issue here is that people are afraid of what happens if they go bust, if they do not succeed, and end up in all sorts of regulations that will basically kill their future perspectives, which is a big difference from the situation in, for instance, the US, where You put on your CV, I've been bankrupt twice, and that's a plus because you've risked something. And then the third time you hit it big. And this, let's say, mechanism, we do not have, at least in the Netherlands. And I think that would really help a lot. That's it. Thank you.
Thank you, Mr. Scho, for this insight also into open pilot lines. So we now have the view open and private setting. The next speaker is Mr. Sauerwein, who will give us also a view about pilot lines and open access.
Thank you very much. Good morning. Yeah, I have the honor to give a presentation about the so-called co-pilot project. As a industry representative, so being a member of the consortia, a user of that within the consortia, and also most probably very heavily in the future. So what is co-pilot about? Co-pilot stands for the pilot facility to produce nanoparticles and nanocomposites. It is supposed to be, it is dedicated to be a open access facility to offer service to SME and other players in the marketplace. Of course, with special nanocomposites intended for dedicated users, programmable functionalities. So what is the market about? I think you're pretty aware of that. Nanocomposites is a very important future market. The chart here on the right-hand side shows a little bit what are the opportunities, but also what are the threats. Because there are concerns about the competitiveness of the European Union versus other players like the United States, like North America, like Asia, talking about China. So the chart on the right-hand side shall show what we would expect based on market figures you can find in different market studies. When you assume market growth worldwide, so for example, it's differentiated between polymer nanocomposites, which is the red lines, where in these market studies we used here as a basis, people say that it grows at an annual growth rate of 18%, and even for polymer nanocomposites, the growth rate is foreseen to be even higher, above 30%. So the dashed lines show you what would happen if the competitiveness of the EU is not strong enough, if we lose against North America, China, and other players. That is really a threat. On the other hand side, the full lines, the bold lines, show you what would potentially be the market share or would be the market size of the European Union, of players in the European Union in these markets. You see the gap is big, so we have to make sure that we have a competitive surrounding here in the European Union to make these markets really come true. The market figures is worldwide figures, and for doing these graphs, the colleagues who did this assumed that Europe can reach 30% of the worldwide market. So this is the bold lines. The dashed lines is the negative scenario. So, and we believe that the access to pilot lines can really boost the competitiveness of the European Union. And you know this picture. Why do we think that it is so important to have these pilot lines? Because the investment costs are much, much less than you do it on your own. It is very important to cap this valley of death between the RTO daily work and the business and the daily work of the business players, of the factories, of the companies, of the producers. And pilot lines is a very important tool to gap this. So what is the basic idea specifically about co-pilot? We are on the way, or we have built within this project, an open access facility to produce nanoparticles and also to incorporate them into nanocomposites. We are offering package of production, the technology, the people who run that thing, who give advice, who are technical advisors on this. We have the analytical instruments, There were two companies involved, or there are two companies involved, who deal with the analytics of nano fillers and nanocomposites. We have people involved in quality, logistics, everything the pilot plant can offer to the outside world. From lab to fab, that's the same. So we like to fill the gap between the current lab scale and the industrial production. And we believe that if people are using our pilot line, this is at much, much lower cost, maybe tens of the cost than doing it on your own. So what is open access in our specific meaning? We want to open the facility to all companies within the European Union and associated member states. We want to offer it at fair pricing. Of course, we have to guarantee that there are clear and transparent conditions, especially in regard to the intellectual property rights, the confidentiality of the systems with which the customers want to show up and use the pilot facility are very important. And what I think is a very important point, because that's especially difficult for SMEs to guarantee, is the safe by design approach. So by the partners being involved in that design of that facility, we can guarantee safety and all these requirements which we have to face when dealing with nanoparticles and nanomaterials. So this chart show what is the nanocomposite production chain we are covering with that co-pilot facility. We deal with the nanoparticle dispersion, where the synthesis basically happens. We deal with surface modification of dispersions, and within these two fields we have heavily involved the analytics, so that the two partners I was talking about and a third partner doing the processing of such liquors, of such nanoparticle dispersions, have been heavily involved in developing here new technologies for online analysis of nanoparticles. And we cover the downstream processing of these nanoparticles in, for example, solvent removement and the nanoparticle dispersion into polymer matrices to come to nanocomposites. It is also a little bit split, so one of the main pilot lines is based at Fraunhofer ISC in Würzburg. The second one is at the TNO in the Netherlands, and the third part is again in Germany, the SKZ, which is more on the nanocomposite sides, whereas the other two are more on the production and characterization and isolation of the nanoparticles. So these are the example cases we deal with within Copilot, and the companies and RTOs mentioned here who are representing these particle example cases. We deal with layered double hydrates, with hollow silica spheres, with titanium dioxide and zinc oxide, and with super paramagnetic nanoparticles. And the application fields we look in is flame retardancy, smoke inhibition, acid scavenging in polymer systems, light stability, of course, lightweight applications, heat isolating, this would be the silica nanoparticles. Sometimes we look into the combination of the two, so lightweight and flame retardancy when we think of a combination of the hollow silica particles and the layered double hydrate. And of course, titanium dioxide and zinc oxide is for the low refractive index polymers. It is for UV protection, anti-glare when we think of the silica nanoparticles. And magnetic particles, that's a very interesting field. This is for for example, one of the applications we are looking into, or the consortium partner look into, is the magnetic recovering of catalyst nanocomposite beads in chemical reactions. So this is shows some picture of the pilot facilities. These a little bit more detail. It is very much a facility where different kind of equipment can be used. It's very modular and can be used in a very modular way depending on the specific case which has to be investigated and to be sized up. What is the business model of the pilot, of this pilot infrastructure? We want to serve two things. One possibility is the one-on-one service to the industry. That means that if an industry player comes to the pilot factory and has already a relatively high readiness level of his development, that is normally a one-to-one scenario using the pilot facility. The second option would be open innovation. This is for industrial partners who are with their development or with their idea and the project as relatively low or low moderate technology readiness. And of course, this is intended to embed the industrial R&D industry, which is in a geographical surrounding of the pilot infrastructure we have set up during that project. And of course, within the local and regional innovation landscape. So this is the proposed modus operandi for the further use of that co-pilot, of that pilot production facility, which has been developed during co-pilot. So it is very important to make sure that there is a long-term commitment and strategic endorsement between Fraunhofer and TNO to make that living, to make use of that equipment, of these equipment facilities which have been built up. And that is why they ask, or the RTOs ask, that there should be a commitment by the regions on joint investment between RTOs and the regions to get pilots started and established with that necessary infrastructure to make them run after the project, beyond the project time, to make them living and be used by the industry. The open innovation model is especially for the larger entities when companies say we have a development idea, but we feel better when combining our strength with other partners and use such a pilot facility to show that the idea or the project can be realized on the pilot scale, and or maybe then the next steps is something which is done within individual one-by-one projects. On the other hand side, for the SMEs, it is important, if we want this pilot plant to be a really successful use, that to really get these people, you know, for some SMEs, even a spending of money, which is not that much of money, is sometimes a hurdle. And so it's important, we believe, that we need to have some dedicated finance instruments, some kind of user compensation scheme to be funding for especially SMEs to use such pilot facility in future. So the one-to-one service is quite obvious. What is the benefit? People can go there, partners can go there and produce nanocomposite in kilogram scale. This enables them to demonstrate their product. They can immediately sample to the industry, or very quickly sample to the industry. They can also use the facilities there to produce the nanocomposites on their own. Upscaling is possible of that synthesis. Adaptation of the nanoparticles into production is possible. And of course, in partnering between the pilot facility and the individual companies coming there, it is possible to improve the equipment, to always further improve synthesis and the processing of the nanoparticles, so that both partners, in the end of the day, the pilot facility as such, can profit from that, and of course the companies using the equipment. Fraunhofer has also the possibility to do coatings on square meter scale already on a very early stage. Characterization is for sure consulting trainee. Especially, that's what I pronounced already, toxicology questions, safety questions, something which SMEs very often have some problems with because it takes a lot of money, a lot of resources. So what is the value for industry? For the one-to-one service, where people can, companies can go there, can produce prototypes, can access quickly to the marketplace. Can make their contacts with the potential customers very quickly and can accelerate their process. The cost and time to new products can be accelerated very, very much. And of course, it is expected that the total sales will increase for these for the partnering companies doing this one-to-one partnership with the pilot plant, with the open access pilot plant. For the open innovation model, where we believe that it's good that companies can group together when the technology ripeness of the project is at a more moderate level. We believe that we can reduce with that pilot facility the time to market of innovation, and that real breakthrough products can be produced on such facilities. And that is also very important if we consider that maybe some large entities can group their forces together there, that we have a much better competitiveness against Asia and North America, where we know if we talk North America, we have very often very big companies as competitors, whereas in Asia we have even more difficult structure of financing, and competitiveness is not so easy for, let's say, the smaller large entities, companies. I believe this is a very good model of this open innovation to bring companies together on new projects, on really breakthrough projects. And this has already been shown. It is very important to get that support from regions. In that project, this has been done, like shown here. And another example is the Brightlands Material, or more specific example is the Brightlands Material Center, where the areas shown here, the Belgian Limburg, the Netherlands Limburg, and Aachen area, as well as the Liège and Antwerp area, grouped together to fund two projects with a relative significant value of money. So this is showing the partners, the RTO partners on top, which have established the open pilot locations, the equipment suppliers. Safety was, as I told you, a very important factor within that consortia, and the industrial advisor, who also gave advice and gave the model systems within that project. Thank you for your audience. Thanks a lot.
Thank you very much, Mr. Sauerwein. Now let's go to Mr. Mogode, who gives us also his view, and coming from a spin-off company.
Thank you, Mr. Chairman. Yes, so hello to everybody. My name is Maël Mogode, and I'm going to explain you an innovative way to create a pilot line, as we did for this company called S2P Smart Plastic Products. So, yeah, as a summary, I will describe quickly the company and the organization, the main characteristics. I will tell a little bit about the decision-making in pilot line participation, the financing, which is very important in that case, some indicators, and then the barriers, the risks, and the success factors of such pilot line, and the main lessons that I learned and the perspective of this pilot line. So, yeah, S2P is a company, first of all. It's a spin-off company of IPC. IPC is the French Technical Center for the Plastic and Composite Industry. And I was previously in this technical center, and we make research and development on technologies during 10 years on so-called 3D MID technologies. And after a European project called 3D HIPMES, which was a pilot line project, pilot platform, we decided to create this dedicated platform through a company. We are specialized in services for designing, prototyping, and manufacturing these smart plastic products. And what we do is the integration of electronic circuitry and components directly on 3D plastic parts. You've got your plastic part here, and we integrate 3D circuitry, tracks and so on, and component to make, 3D electronic device. This is a source from Festo. This gives you the possibility to integrate electronic really in 3D. You can make optical components, you can add switches, actuators, sensors, you optimize the design, you optimize the cost, connectors, batteries, etc., etc. This is a really new way to design and to create 3D electronic devices. Our goal in S2P is to give the industry the possibility to first develop and manufacture these new products without having to invest heavily in the short term on the means and the skills. This kind of technology are quite expensive in investment and skills, and this is our main objective first. Then the second objective is to transfer these technologies to partners wishing to invest. And last but not least is to benefit from technological incubator and through the development of emerging technologies is this kind of field. We have to cover in this pilot line the full process chain to bring the product up to production. So we come from just an idea, then we make product developments, we test, then we go into, let's say, development phase of a product, and then after testing, we go into production. This is the main objective of this pilot line. So S2P is SA. It's specific. I don't know if it's very well known in other countries, but with executive board and a supervisory board. So I will explain why later. So it's a quite complex structure for a small company, but it has its reason. We are 7 employees now, with a multidisciplinary team of technicians, engineers, and doctors in plastics, mechanics, chemicals, and electronics. And up to now, we are covering, if you look at the let's say the production chain, the value chain. So we are covering the product design, we manufacture the plastic parts, we make selective activation, let's say, and then for the moment we stop here and we are going to invest in the end of the value chain, which is plating, metallization of the plastic part, solder components on the surface, and then quality control to be fully equipped to make production. So yeah, SA with executive board and supervisory board, we create a company with a capital of 350,000 euros. We've got 11 companies as stakeholders of this spin-off company, and these 11 companies were believing in these innovative technologies. We've got also, of course, the technical center, IPC, and we've got a cluster, which is a plastic cluster in France, Plastipolis, which is here to disseminate these activities. The technical center has got 35% of the company. This was mandatory and asked by some of the companies to keep, let's say, the decision impartial, so that no one industrial make big decision for his specific market and so on. So the technical center has got the majority of the equity. Okay, and of course the ownership is private, and we have other organizations involved here because the state is granting the company, the region is granting also giving some grants to the company, and we also have a scientific consultative committee with labs and other companies around this. And our main activities is design, development, and small series for these smart plastic products. So let's say that the technology is ready. We saw previously that we have to start with mature technologies. This is the case, and we have made mainly lots of demonstration and demonstrators. But now we need to go from demonstration, qualification, to go to small series, pre-production and small series. For the moment, we don't have specific market, let's say, neither automotive or aeronautic and so on. As soon as the customer needs electronics integration, we'll see when reaching our first series. And what I can say now is our first series is going to start with aeronautics. So maybe with the time, we will drive the company towards aeronautics application. But yeah, for the moment, it was not completely defined. It's fully open, let's say open. there is confidentiality and so on, but everybody can come to us and develop a product. And the turnover is created by product development projects and product manufacturing. What was the decision making this pilot line? The main triggers for our decision to participate in the pilot line are the following ones. First of all, the research and development was done already on the technologies. Okay, and the need was more to find new products than developing again the technology. The ticket to enter this technology is quite high for companies, even for big companies. We are dealing with plastics, chemistry, and electronics, and moreover, you need transfer skills to invest in such technologies. The example is when you come from the plastic industry, it's not easy to invest in electronics skills or equipments, and the same for the electronic manufacturers. Then industrial customers, they were asking for more than 5 or 10 prototypes. They were asking up to a few thousand parts. For some industry, you need 2,000 parts just to make the qualification tests. And working with small equipment or in a lab, this was not possible. Okay, so we needed something bigger, working on real conditions. And this is a key point. We wanted to create a company because companies want to deal with companies. This is what I learned. They like to deal with companies because they know, or we know, the problems we can have in a company. Okay, then we decided to make it inside, so to integrate the design, the development, the prototype, and the manufacturing, everything inside, in the company. Our objective is to be able to manufacture 100,000 parts per year for pre-production, small series, and so on, all projects included. And afterwards, we've got a transfer for bigger productions because of quality means. This is not the same thing when you deal with millions of parts. And obviously logistics. If you're dealing for automotive industry and so on, you need to bring the parts where the companies are. So in Brazil, in whatever. So it's not the same work. It's not anymore only production. It's logistics. And then also we work closely with university and technical center to be able to invest in the next generation of technologies. Okay, the financing here. We've got a budget in 5 years of 6 million euros. The return investment in the value of the company, expand the stakeholders' activity by attracting new customers on new markets and offering new function of their products for their existing customers. Yeah, we can valorize already work for PEPs, or it's IPC, and then employment for French authorities. They give money because we create employment and activity. I'm going to go quickly here on the performance indicators, but we need to bring some indicators to show that the platform, or the pilot line, or the company is working well. So we've got, it's like a standard company. We've got indicators on the turnover, of course, of the company, on the quotation success, on the sold hours per people. Here, all the people we have, they need to work, of course. Of the created jobs, number of customers, and the ratio of SMEs and groups, big groups, let's say. The number of products developed, the equipment's use rates. This is also a key point. When you create a company and you invest in some equipment, you cannot use it 1% of its capacity. And when you are making pilot lines, you are using industrial equipment, and they are very expensive. So you need to bring more and more product to be manufactured on it to make it attractive. We still R&D projects, number and transfer projects. We need to disseminate, of course, and these are key points also. Quality, security, environment. This is a new problem when you create a company and when you make production. At this moment, I'm facing problems with environmental problems in France because I'm using big chemistries. And when you are in a lab, it's okay, you can play with your chemistry. But when you're dealing with hundreds or thousands of liters of dangerous products, Then you've got other regulations, and it's not the same thing. Yeah, okay. So then, the main barriers for us in our experience. So the costs, of course, especially for high volume markets that compete with low-cost countries. The cost is a key problem. Then qualification, especially for some high added value markets. If you work for medical, aerospace, and so on, you need to bring the qualifications, or you need to show that your parts or your products are qualified for such markets. And then interdisciplinarity of the technology. When you're dealing with plastic and electronics, you've got the designing, which are different. You've got the quality standards that are different, and you've got to merge. You've got the purchasing chain, which is not the same. And of course, education and training that are not that are different, and you need to merge them. The risks. Our goal is to bring TRL 4.6 products to TRL 9, clearly. And pre-production business model are not easy. You take all the risks. We are taking all the risks, and need high quality management. And when the product is ready, then you transfer in mass production. This is not an easy business model. But then with such model, private investors are different. It's difficult to deal with business angels or capital risk with such a company. That's why we went to industrial people that believed in this technology, and the equity has been done with industrials wishing to increase their activity with such technologies and use the company as a technology subcontractor or provider. This is very important. The business angels would never have been put money in such a company. Then the success factors. First point is to be recognized as a technical expert in the field. First thing is the techniques, of course. Then you need to start with high TRL processes that show that it's possible to make products technically and economically. And another point, remember that if you're alone, there is a mistake somewhere, and the industry doesn't like it. There are several pilot lines like us in Europe, and this is very important for our industry. Because if you're just alone, a company will not put or buy you some products because it's too dangerous for them, for the purchasing, of course. Then another point is public-private partnership. This is obviously very important. We needed public funding to start. Without public funding, we wouldn't have never been able to create this company. And it has to be, for me, it has to be done through a company with profits, but not necessarily huge ones, and with low yields, at least at the beginning. The stakeholders are not expecting the investment back before 5 or 10 years. This is not the same thing as business angels or capital venture. And of course, the success factors are dealing with people. People, it's a human history here, and without the people working all together, it's not possible. So okay, here again, the main lesson learned, if most of the company lost the know-how and were subcontracting. We see a change in the strategy as they lost too much. And you can use TRL 9 technologies, but what for? The work is not finished. You need to bring some products to TRL 9, not only technologies, which is another story, of course. And it's easy to make products demonstrator. In many projects, we can see demonstrators. We made several demonstrators and so on. But when it comes to 9, you need to prove the reliability of the product. And this is a key point for us when we want to reach or to go through this valley of death, of course. And you need to use a large network, research, industry, institution, of course, at several levels, local, national, and European, international level. You need to keep some time to make research and development because it's very important for the future of the company or of the pilot line. And you have to be patient. It took us 4 years to create the company. So just, with many problems with all the local or national levels, creating folders and papers and what you want to create it. So you have to be patient. This is what we learned, Yeah, sorry. Yeah. Thanks for your attention.
Can you give me that? Okay. For this extensive view about the pilot lines, and I'm just looking at my tablet here, and I think there are various questions popping up, but I think the predominant one would be, one is, as we heard, most pilot lines are open. Now, we also have, of course, industry interested in, say, more private funded pilot lines. So can we deal with that as a continuum? Is it open or private, or is it an open pilot line can also be private? And the other one is, if we, after 2020, when Horizon will finish, is there still a need to fund pilot lines, or is then the infrastructure established and the SMEs are queuing up at the door to finance them and look forward? Because at some stage, of course, we have now a demand, but can we really get industry then also using all these pilot line extensive? So maybe that's the question I would just give everybody an opportunity to reflect on. And yeah, please go ahead.
Okay, thank you, Gernot. Okay, I will try to briefly answer those two questions. On the one hand, this discussion about open and private, I would say that, of course, open pilot production facilities are the best option to give the opportunity to SMEs to access to the services that these pilot production facilities could bring. But concerning higher TRL projects, then this case of innovation actions that I have shown in my presentation, for example, this ISADI project, for example, when we are talking about bringing upscaling the pilots from TRL5 to TRL7, then TRL7 is relevant, a demonstration in a relevant environment. It means, or operational environment, it means the pilot should be at industrial sites. So then we start the discussion about these confidentiality aspects of industry and the ownership. So I would say that even private access pilots could be somehow negotiated or could be in an open way for example, for providers of industry. And so even if they are private at first stage, then could be semi-open for the users of providers or clients of these industries. And then the second question about if this instrument should continue in the next framework program or in the next calls, I for sure agree with this idea. I think, all the presentations of all the speakers, I think we have mentioned this, the benefits of this instrument, that like reducing risk, for example, bringing new nano-enabled or enabled products into the European market, helping SMEs to improve their competitiveness. So many benefits from this instrument, and I will for sure support this instrument to continue in the future. So I give the opportunity to next speaker.
Maybe I can enlarge the question. Also, as a commissioner of RTD, is very much focusing on open to the world. Is it then open to European companies, or is it open to everybody from the world to come to test in your facilities?
Especially in our case, I can only talk about our cases, of course, we aim to serve the world. So it's not restricted to the Eindhoven region, the Dutch region, the European region. We serve customers who are willing to pay for our services. So if you want to restrict that to a certain area because of funding that has gone into setting up such a service, you also restrict the chance of a successful operation in the end to be self-sustaining. So I think it's really important to keep this open mind. We bring a lot into the European area, but it also helps to have customers coming from other places in the world to help support us in that sense. Well, and one thing about open access, I also believe in open access, but it is important to define what you mean with open access. Because in many cases it will be very difficult to have people come to your line and do work on your line by themselves. Open access very often means that people can make use of services based on these pilot lines, have access to products that they could otherwise not access to. And that for me is the essential definition of open access. You enable people to make use of services that are there.
Yeah, I fully agree in your definition of open access, because otherwise it wouldn't make sense. Because I think talking as a user of such pilot facility, as a large enterprise, a small large enterprise, I have to say. Yes, because we can make use of the experience, of the knowledge of the people there at these pilot lines. And that's the way we understand it. We would never ever come to the idea that we go there and use it as such, as without having any involvement with the people there. Of course, I fully agree in that definition of open innovation. I think that is the way also co-pilot as a consortia sees that. Regarding the future use of pilot lines, I fully agree to make it open to the world. Of course, about the financing, you can differentiate. Forget about the money which went into. So we should use the established facilities to everybody. So also outside the EU. Of course, the funding for SMEs to make them motivated to use it, that is a different story. That is there, whereas the other partners coming from outside Europe have to pay full fee, and European SMEs get some subsidies to get the right products being developed with the help of such pilot lines. That would be my opinion on that.
Yeah, just to comment on the term open. So in our case, we are a private company. We need to make turnover. So everything is open as soon as you deal with business. And it cannot be done by some external people, because specific technologies has to be done by people that learn on it, that have been trained on it, and so on. Now we deal with confidentiality. With all of the projects we have, we've got NDA before, and we cannot speak about what we're doing with our customers. And also, I explain you that I have got a council with my stakeholders, and I don't say to my shareholders what I'm doing with my customers. This is very important, and I'm just telling I'm working for automotive industry or aeronautic industry and so on. And this is because I can make some business with a competitor of some of my shareholders. So, but as soon as you make it's business, so as soon as they pay for a service, then I will make the service for them, and this is obvious.
I've got a slightly perhaps different viewpoint on open access. One of the things that we're finding with some of our clients that are coming close to market is that they do need to be able to operate the equipment themselves and have a good understanding of the manufacturing process intimately. So we offer our clients a kind of journey through our facility. We start off helping them make demonstrators of their product, and we call that activity for you. So we do things for the client. If that's successful and they get follow-on funding to go to, say, proof of concept or say a small-scale field trial, they may want some of their engineers to come into our facilities and learn about how things are done, perhaps conducting the testing for themselves. So in that phase, we're doing work with the customer. So we say we're doing that with you. And finally, in the tertiary phase, as we're getting closer to product launch, actually the client needs to know intimately how to operate the equipment, what are the factors affecting yield, and they need to start building their own know-how. And in this phase, this work is conducted by them, and we say it's by you. And in the case of some of our clients, particularly who are launching, say, biomedical products, by conducting that work themselves, they're able to take on some of the product liability aspects associated with the clinical trialing stages. So the Institute is providing the assets and some of the background know-how, but the client themselves are developing their own new know-how and taking on some of the product liability concerns.
So thank you very much for this interesting discussion. I think Pilot Line will keep us on our heels for the years to come, and I think maybe in 2 to 3 years we also will see, has it really improved the speed to market, and has there really been significant participation and success against, we would say, competitive other regions of the world, and then we will see. Thank you very much, these speakers. Thank you very much, the organizers, and thank the organizers for track record and timekeeping and the excellent organization. And see you soon. And I think at 15 and 10 minutes, the other sessions are starting. Thank you very much. And the other questions that were on the slide, they were addressed to various people. Maybe you can use the 10 minutes of the next coffee break to have an answer to that one. Sorry for time.